Yes, ma'am.
Okay. So can we wait for like 5 minutes for others to join us?
Okay, ma'am.
Okay,
I hope it's okay by us.
Yes, it's okay.
Okay. So in the next 5 minutes, we'll start our lectures so that others can.
Yes, we can.
Yes, ma'am. Can hear you.
So can we start the lectures now?
Yes, ma'am. Yes, ma'am.
Yes.
Okay. So let me start by sharing the PowerPoint for this. Can we all see the slides sharing?
Yes,
Yes,
ma'am.
Okay. Okay. So this is ENS 723 class, and the course title is Municipal and Industrial Waste Control. I am by name Dr. Scholastica Ene Abba. So I'll be taking you for the next 2 days, that's today and tomorrow, after which my senior colleague will take over. So these are the course contents in this slide, okay? These are the course contents that we'll be looking at. And some of the course this course now, participants should be able to define some basic concepts relating to municipal and industrial waste. Participants should also be able to categorize waste sources or characteristics based on origin and management. We should also be able to describe the of municipal solid waste. Also state the principles of municipal solid waste. State the basic/general principles criteria for the ENS on outline the components of integrated sustainable waste management and also classify the functional elements of SWM/strategy and their attributes. First, okay, solid waste and solid waste management. So we are going to be looking at the definition of solid waste. Of course, we all know that the term waste is a term. Why? Because waste to Mr. A might not necessarily be waste to Mr. B. That is to say that what a person sees as waste might be useful to another person. So in this context, we say that solid waste is any unwanted or discarded solid material from residential, commercial, industrial, mining, and agricultural activities that can cause environmental problems. Now, when we talk about waste from our residential areas, from our commercial area, industrial area, mining area, agricultural activities, there are different types of waste that can come from these places. Now, before we go to the next slide, let's look at some of the waste that can come from our residential area, which can otherwise be known as household waste, right? So waste from our residential area can be termed household or domestic waste, okay? So once you hear about residence, that's residential, of course, that's where our living areas, our homes. So we can say that waste generated from homes and living areas are termed residential waste. Examples of such waste are, we have the food waste. This food waste can be leftover food. It can be fruit peels. I'm sure some of us, before attending this lecture, in the course of having our breakfast, there were some waste, there were some quantity of food that was left behind, of course, some of which some of us will not go back to eat. And before we go back, the food is already spoiled. And the next thing to do is to do what? Is to trash the food, which is now known as the waste. That's the leftover food. Another waste that can come from residential waste is our plastics. Okay, so this plastic can be in form of sachet, water. It can be in form of bottles. The plastic can also be in form of our nylon bags. Okay, so paper and cardboard can be from our residential waste. We have the glass bottles, used clothes and shoes. Even some of us that have children, we have babies that use these diapers, right? These disposable diapers are also known as waste from our residential, from our homes and from where we live. Like other examples of residential waste are, we have the ash from cooking, the e-waste. When you hear of e-waste, what it means is what? Electronic waste. So this electronic waste can be our old phones that we are not using any longer. It can also be our batteries, right? Sometimes we have gadgets that uses batteries, our remote controls and what have you. When the batteries go bad, they are all termed as residential waste. We also have garden waste. Where we live, we have gardens around us. This garden waste can be leaves and it can also be what? Grasses, okay? So from our definition of solid waste, we also mentioned the commercial waste. Commercial, as the name implies, simply means waste generated from our business places and service activities such as markets, it can be shops, offices, banks, and restaurants, okay? And examples of such commercial waste are, we have the packaging materials like, of course, uh, shops and markets, they make use of cartons, plastic wraps to package materials. So all these cartons are waste at the end of the day. We have the expired goods too from supermarkets. Of course, no one will want to use things that have expired. And at the end of the day, they are being trashed. So all those expired goods are also known as waste. Then we have the office waste such as paper and the printer cartridges. We have food waste from restaurants and hotels. Even the broken furnitures too, in our offices, in our banks, they are also known as waste. Okay? Then we have the polythene bags from markets and also the used cleaning chemicals. All these are known as commercial waste. Okay? Then let's go to uh, the next type of waste, which is the industrial waste. Industrial waste, of course, as the name implies, waste from our industries. So these are waste that are generated from manufacturing and processing industries. And examples of such waste are, we have the chemical sludge. Now, when we talk about sludge are what? They are semi-solid substances, right? That are what? They are actually thick, that are gotten as what? Waste from our production, industrial processes, okay? We have other examples of industrial waste such as the scrap metals, waste oils and lubricants, industrial wastewater, Most of these industrial waste to some extent are what? Hazardous. And examples of these hazardous chemicals can be acids, it can be alkalis. There are some solvents that are used in our manufacturing and processing industries that are what? Hazardous. That is when you talk about hazardous, it means they are harmful to our health. The plastic production waste there. Okay, so for the mining waste, we all know what mining is. Mining activities. Okay, it has to do with extraction and processing of minerals. So waste that are generated in the course of extraction and processing of minerals are known as the mining waste. And examples of such are, we have the waste rock, we have the heavy metal contaminated water, right? And even when you are mining, of course, in order to get to the minerals, right? You know, we usually dig the soil and remove rocks in order to get rich to those minerals. So the soil and the rocks that are being removed are known as waste. So mining metals like lead, mercury, arsenic, and what have you. Agricultural waste, agricultural activities. Waste can also be generated from our farming and livestock activities. So when we say agricultural activities, we mean that waste from farming and rearing of livestock and what have you. So examples are, we have the crop residues. Some of the crop residues like the straw, the stalks, husk, etc. We can also talk about the bags we use in what? Putting our fertilizers. At the end of the day, after we use the fertilizer, that bag is termed as what? Waste. Of course, we have our animal manures. We also have the containers that carries the pesticides. We have dead animals. We have the irrigation runoff. So all these are termed as agricultural waste. And all these waste that have been mentioned from our residential, commercial, industrial, mining, and agricultural activities, if not properly checked, they can cause environmental problems. Now, the next slide takes us to solid waste and solid waste management, conceptual clarifications, right? So this will help us to understand what solid waste management means, okay? It helps us to understand what solid waste management is. So from the slide that is presented before you, it says that solid waste management comprises of purposeful and systematic control of waste at various stages of generation, collection, transportation, recovery, processing, and of course, disposal of solid waste. For some of us, this definition or the terms that are used here are new, right? And that is why you can see that I'm taking my time to explain this for us, so that in the course of our reading, it will be what? Easy to understand. So, the purposeful and systemic control of waste at various stages of generation, of course, it has to do with what? Solid waste management has to do with organized handling of waste, okay? If waste is not generated, can we collect such waste? The answer is no. And that is why you see that solid waste starts from what? The management starts with what? The stage of what? Generation. Generation of waste, as far as we are concerned, is inevitable. At every point in time of our life, we tend to do what? Generate waste. Okay? So, the organized handling of waste from the point these waste are being produced until the final disposal must be in a way that protects our public health and the environment. Okay? So the thing is, it is not just dumping of waste. It has to do with what? Step-by-step system. Okay? For us to manage our waste properly, it has to undergo the step-by-step system. Now, Let us look at the stages of solid waste management, okay? The first step, like we mentioned earlier, is what? Generation of waste. This simply means where waste is produced. I'm sure before we left our homes, we generated one or two waste. Probably we took sachet water, we took maybe sometimes roadside food that maybe was like this apple pie that was what put in the leather for us. Okay, so examples of waste that is produced are waste from our homes, and we have mentioned that from our residential areas, domestic waste. And in the course of our explanation, we say that this domestic waste can be what? Leftover food, otherwise known as food scraps. It can also be in form of plastics, okay? Generation of waste can also come from our markets, our industries, hospitals, and farms, like we have mentioned earlier. So one thing I want all of us to know in this lecture is that waste management begins the moment waste is what? Created. Waste management begins the moment waste is created. So that is it about waste management. The second we'll be talking about is what? Waste collection. Okay, waste collection. This simply has to do with gathering of waste from our homes, our shops, industries, from all the places that waste can be produced. So the way we gather waste, okay, it matters a lot, right? And examples, what are the things we can use to gather this waste? We can use our waste bin to collect waste. We can do the house-to-house collection and also the community collection points, okay? These are points where members of that community go to drop their waste, okay? Now, this collection of waste is what is very important. It is not just by going dumping waste at a particular what place or site, right? Like the open dumping. It is not just by dumping it. Okay, this waste has to be collected properly. Why? Because if you don't collect your waste properly, of course, what happens? The environment will be what? Will be smelling. It will lead to odor, okay? And then you see flies, you see rodents will just be perching on the waste. That is known as the vector breeding. And this can also lead to spread of diseases, right? So we know what management means, okay? So the way we also collect our waste matters. The next step is the transportation. As we all know that transportation simply means movement from one place to another, right? So in transporting our waste, it means that we are moving our waste from the point it is being collected to treatment or the disposal sites, okay? From where it is collected to the treatment or the disposal site. And how do we collect our waste? After collecting this waste, how do we transport this waste to the disposal site or to the treatment site? This is done, transporting of our waste is done by using the compactor trucks. It can also be done by using open trucks. But sometimes, in fact, oftentimes, open trucks are not usually what recommended. They are not recommended because, of course, when you are going and you know breeze, because of breeze and all that, it can cause littering and environmental pollution. Okay, now the recovery stage. This recovery stage, it has to do with what? When you talk about recover means what? Getting useful something from what? Something. When you want to get useful something from something, and that something usually is what? Waste. It means extracting useful materials from our waste. Now, in extracting useful materials from our waste, there are different processes that this can be done. We have the recycling of plastic, of course, right? We have reusing bottles. All these are ways we can manage waste. Reusing bottles, for instance, let me give an example of this reusing of bottles. Of course, we know that at every point in time in our life, we lose a lot of water, and that is why it is encouraged to take a lot of water. And in a situation where we go out, and then for every point in time, especially now that the rate of dehydration is high, we go to supermarkets, we go to people selling by the roadside, we get bottled water, or even sachet water, okay? And at the end of the day, after taking the water, what do? We trash it by the roadside. We just do away with the sachet water, ladle, or the bottle. All these are what? Ways that have been created, right? So in reusing bottles, the best thing to do is what? I know each and every one of us that are listening to this lecture this morning, of course, we have bottled water at home, right? We have bottles that we can always carry our water. We can always put our water. Why not move with the bottled water so that when we are thirsty, we can get this water to drink? So another way of recovery of waste is recovering what? Metals. Recovering metals, you see these waste pickers. They usually go with this their truck, they go to waste bins, open dump sites, and they get metals, scrap metals, where they sell to the dealers, and the dealers now will sell to those that are into production so that they can recover useful materials from it. So in the course of doing all this, of course, we reduce the amount of waste that are being produced, right? Another way of recovery is what? Composting organic waste. Organic waste are waste that are what? Biodegradable, right? So composting at least is also a way. If we can get our organic waste and turn that organic waste into what? Fertilizer through what? Anaerobic or aerobic composting, at least to get our biogas, to get our fertilizers, to get our compost manure that will what? Help to increase the fertility of the soil, structure of the soil, and of course, it will bring about what? High agricultural yields. So when all these things are what? These processes are used to recover useful materials from our waste, you can see that to a very great extent, to a larger extent, our what? Waste is being what? Managed, okay? So now, the thing is, waste is not always waste, right? From what we have said, you can see that waste can be a what? Can be a resource, right? It can be a resource. And that is why it is what? Very good to recover waste. Now, in recovering of waste, if you look at the pictorial that is presented before us, there are different ways we can recover waste, like I mentioned, through the anaerobic digester. That it has to do with when waste is put in the digester, there is what? Decomposition by microorganisms in the absence of what? Oxygen. So this helps us, it generates biogas and fertilizers too. These biogas are the waste to energy that are used by industries to sometimes power their machines, and which is used in what? Production. We see another way we can recover waste, which is the compost and also the incineration. Incineration is the burning of waste at high temperatures, right? And this incineration helps us to also recover what? Energy, because of course, when heat is burnt, a lot of heat is what? Is supplied. So in terms of processing, that's the treatment, right? From the recovery is the processing. That is what I have just explained, where these organic waste are kept in the digester and is broken down without oxygen, like I mentioned, okay? So, but one thing about the incineration that we must know this morning is that incineration must be controlled. Why? Because so as to prevent air pollution. Sometimes, oftentimes the air that is being released can pollute the environment. So, but it also helps to reduce, of course, when something is burnt down, the amount of waste that is generated is reduced drastically. Then for the disposal, which is the final displacement of waste, right, that cannot be reused or recovered. This slide shows the sanitary landfill. Sanitary landfill usually are engineered sites, right? They are engineered sites that are what? Constructed for what? Waste disposal. And that is the best form of disposing our waste. That is the best place to dispose our waste. Why? Because the sanitary landfill, they have liners that helps to prevent, they are constructed in such a way that they have liners, and these liners helps to prevent groundwater contamination. right? And also it has the gas collection gases that are usually produced, especially example the methane gas that are produced and can be detrimental to our health. They already have what the collection systems in the sanitary landfills that checks that. Also, leachate in the landfills are what treated. So you see that from the waste generation to the final disposal, our waste are being managed appropriately. So it is a step-by-step, process of what managing our waste. So the next slide presents solid waste sources or classification based on origin and management. Hello, class. Are we together, please?
Yes, ma'am.
Yes, ma'am.
We are together, right?
Yes, ma'am.
Okay. So the solid waste sources now or classification. So we are going to be looking at the sources of solid waste and also classification based on origin and management. Okay. As we all know, earlier we said that solid waste is generated from residential, industrial, commercial, agricultural areas, mining, what have you, that's the ETC. Of course, we know municipal waste, right? Municipal waste include waste, that is garbage and rubbish from our households, from our offices, from our hotels, markets, etc. And also from the street refuse, such as the street sweepings, dead leaves, contents of litter, receptacles, etc. So we have the municipal waste and we have the industrial waste. Of course, like we mentioned, waste from our industries, right? Attempt industrial waste. So industrial waste are broadly divided into two. Industrial waste are broadly divided into two, and these are the non-processed waste and the processed waste. Okay? Let's start with the processed waste. The process waste comprises of waste from respective industrial establishments. That is to say, we depend on the type of product that is being produced. So what this is talking about is what? Waste that are generated directly from industrial production or manufacturing process, okay? Directly from where our products are being processed and manufactured, are being produced and manufactured. That waste that is generated at that point in time, they are known as industrial waste. Of course, this industrial waste can come from raw material processing. They can come from our chemical reactions that takes place there in the industry in the course of production and in the course of manufacturing our products. And also we have the manufacturing operations. Then the equipment that are used in this production, right? So this waste that comes from there are known as a processed waste. And examples of this process waste are, we have the sludge from chemical processing, from our chemical reactions. We have another one is the wastewater from food processing factories. We have the sawdust from wood processing, and there are many of them. There are many of them. So why this of this waste? Of know that most of the raw materials we use in our industries, they contain what? Heavy metals. They contain metals that are toxic to us, right? And of course, most of the processed waste, right, because they contain these heavy metals. Therefore, they require treatment before they are being disposed. Treat the waste and then you now go off to dispose it. Of course, it will lead to environmental what? It will potentially affect our environment, degrade our environment, and it will lead to what? To affect our health, right? So the non-processed waste, such as we have the office, we have the cafeteria waste, packing waste, etc., they are common to all industries, okay? So simply put, we can say that non-processed waste are what? Generated from general industrial operations, okay? Not from the product making process itself, of course, non-process. Not while you are directly producing or manufacturing your product, not the waste that is being produced, but the one that is what? The one that is generated from the industrial operations. And some of these waste can be the office paper waste, it can be the food waste from factory cafeteria, broken furnitures, used cleaning rags too, right? And the characteristics of this waste, let's look at some of the characteristics of this waste. Of course, these wastes are similar to municipal solid waste. So we can say that the non-processed waste are municipal waste, that municipal solid waste. They are less hazardous, yes. They are less hazardous compared to the processed waste. Of course, they are very easy to manage, right? And then we can also recycle some of this waste. Of course, why are we recycling? So as to get useful or to recover useful products from it. So for the non-processed waste, they can be recycled. Okay. So let's look at the characteristics of municipal waste. Characteristics of municipal waste. Now, when we talk of characteristics, we have mentioned what municipal waste are. We have mentioned what municipal waste are, waste from our residential areas, offices, markets, and what have you. Now, what are the major characteristics of this municipal waste? Okay, so when we talk about characteristics, you see, we are talking about what are the special features that tells us that these waste are what? Waste. Okay, that's features. What are the qualities? What are the properties that describe something, right? That describes something and makes that thing identifiable or distinguishable from others. Okay? So we'll be looking at some of the characteristics, like the physical characteristics, we'll be looking at the chemical characteristics and the biological characteristics. And of course, we'll not just look at them, we'll look at the various examples that are involved and what? Why the definitions or the meaning of those examples, right? So for the physical characteristics, they include the specific waste weight, the moisture content. We'll be talking about the particle size and the size distribution, and the what? Permeability of the compacted waste. Okay. So when we talk about the specific weight, what do we mean? Specific weight simply means the density of the waste, right? It simply means the density of the waste. And the specific weight is simply the weight of waste per unit volume. What is that weight of waste per unit what? Volume, right? Now, when we're talking about the weight of waste, it tells us how loose, either the weight is loose, of course, loose weight will have low density, right? And then compacted waste, when something is compacted together, like they are heaped, of course, that thing will what? It will be heavy. And because of that, we say it is of high density. So now, why is this specific weight important to us? It is important to us because it helps us to determine the size of what? Collection trucks. That's the trucks that are used to collect the waste. For loose waste, compacted waste, we need what? We need a bigger compacted what? Truck. It also affects our transportation cost, of course. The compacted waste, of course, will be more harder to what? To transport, and so it will be more, the transportation cost will be expensive, right? And then let's look at the moisture content of waste. The moisture content, of course, is the amount of water present in the waste. Okay? Amount of water that is present in the waste. So what moisture content tells us is whether the waste is dry or wet, right? Whether our waste is dry. That's why sometimes when you see this Bensesa truck, or you see them transporting waste from the point of collection to disposal, when you see them, sometimes you see that the waste are being littered about, and then you now see in the course of movement, as the truck is moving, you see a drop of water coming down from the truck. Okay, so that is to tell you that that waste is not a dried waste, that the waste is wet, right? And of course, we know that our organic waste have high moisture content, while the paper and the plastic waste, they have low moisture content. Okay, the moisture content is very important to us because it affects the weight of our waste, right? So for waste that has high moisture content, that's waste that have high amount of water in it, will definitely be heavy compared to the ones that do not have, right? And also when we have water in our waste, especially our organic waste, what happens? It what increases the rate of decomposition. Okay, because microorganisms, they decompose in what? The rate of decomposition increases with what? The presence of water. Okay, and then it increases the leachate what? Formation. When we talk about leachate formation is what? The slow downward movement of water from waste to what? Our surface water, to the ground. It passes slowly to the ground and probably goes to the water surface that what it helps it pollutes. And then even though incineration, of course, incineration has to do with what? Burning of waste at high temperature. So a situation where wet waste is put in our incinerator, it will be difficult to burn, right? It will be difficult to burn. So it reduces the efficiency of the incineration. And for particle size and particle distribution, it's simply the size of individual waste components. Okay, it has to do with the size of individual waste components. And of course, our waste particles can be large. It's an example is a medium, the bottles and cartons, right? It can also be medium size, like the food waste jugs. And then fine particles like the ash, all these are termed as a small waste. So this is important because it affects compaction. Of course, the smaller particles will easily be compacted together than bigger particles. It also affects the composition rate, right? Smaller particles will be decomposed faster than the larger particles and determines the screening and the sorting efficiency. This has to do with what? In the treatment process. The larger particles are easily sorted out. They are easily screened out in the course of treatment than larger particles. Then the last but not the least is permeability of compacted waste. Permeability is the ability of compacted waste to allow liquid or gases to pass through it, right? Of course, it tells us how water, rainwater, and the landfill gases can move through the waste. Okay, like I mentioned about leachate not long ago. I say leachate is what? The flow of water. This water can be rainwater. It is the flow of water from that passes through the what? Different layers of waste. Okay, it passes through the different layers of waste to the soil, to the ground, and what? It reaches the groundwater. Okay, and this is important because it affects the groundwater contamination rates. You see, so when this leachate gets in contact with our groundwater, it will definitely pollute it because it has what? When this leachate, when this water passes through the layers of our waste, they tend to do what? Dissolve the pollutants that are in the waste, in the soil. So that dissolved water mixed with pollutants is known as the what? Leachate. And when this leachate gets to our underground water, what happens? It pollutes the water. So highly compacted waste, of course, have low permeability, while the loosely compacted waste have high permeability. So that is that for the physical characteristics, and I hope we understand it now. So for the chemical characteristics, we'll be talking about the municipal solid waste that are combustible and the ones that are non-combustible, right? So, and the feasibility of this combustion, they depend on the chemical composition of the solid waste. Chemical composition in the sense that they contain the carbon, the hydrogen, and what? Sometimes sulfur. Okay? So, Combustible, as the word implies, simply means waste materials that can burn. Okay, they can burn if you ignite it, if you light it up, they can burn. And the non-combustible material are the ones that cannot what? Burn. Okay, so and this classification, of course, why we classified our waste as a combustible and non-combustible is that when they burn, of course, the combustible materials that can burn, when they burn, what happens? They release what? Energy. They release energy, and also energy systems and the thermal treatment what? Processes. So combustible waste are simply waste that can burn in the presence of what? Oxygen. And of course, after they burn, what happens? Like I said, they produce the heat, energy. And materials that are usually combustible, these waste materials are mainly made of organic substances. Okay? Of course, you know that organic substances contain carbon, hydrogen, and sometimes what? Sulfur. So organic substances are mostly what? Combustible materials that can what? Burn. And examples of these organic substances are examples of combustible materials. That's waste that can burn are, we have the paper and the cardboard, we have plastics, we have rubber, wood, we have food waste. That's when they are dried, because we know that food waste are organic waste and they contain high moisture content. So when these food waste are dried, of course, they can be burnt. Okay, and like I said earlier, this waste burn because they contain carbon and hydrogen. Why this is important in waste management is because combustible materials, they influence incineration design. The way we design our incineration matters. It helps to what? Influence the what? Design of our incineration. It also affects energy recovery what? Potential. Of course, waste that can burn, a lot of energy can be what? Can be gotten from it, from the heat that is generated after the burning process, right? And it determines the heating value of what? Of the waste. So the higher the combustible content, the higher the energy potential. That is it, right? And of course, the opposite is the non-combustible. If combustible are materials that can burn, non-combustible are materials that do not produce significant heat. Why? Because they cannot burn when they are exposed to fire. An example of such waste is what? Glass. We all know that glass cannot burn. Metals cannot burn. Metals like aluminium, iron, they cannot burn. Stones cannot burn. Ceramic, sand, ash, soil, all these are waste, and we all know that this waste cannot burn. So the reason why this waste cannot burn is because they do not have organic carbon, right? They do not have what? Organic carbon. And because they cannot burn, heat cannot even be released during combustion. That is it. And the non-combustible material, in as much as they cannot burn, they are important in waste management because they affect the furnace efficiency, right? And they also increase the ash residue after incineration. So for the biological characteristics, excluding the plastic, rubber, and the leather, the organic fraction of most municipal waste can be classified as what? Water, cellulose, fat, oil, and wax, and then protein, right? That is to say that biological characteristics, right? It has to do with what? The ability of that waste to be able to what? Be decomposed by microorganisms. When we talk about biological characteristics, can that waste be broken down, be decomposed by microorganisms? When we talk about microorganisms, we are talking about bacteria, fungi, etc. Okay, so it tells us, it classifies waste according to whether they can be broken down by living organisms or not. Okay, so the main biological categories of this waste is whether these waste are biodegradable, non-biodegradable, and the infectious, that's pathogenic what? Waste. Of course, we know what biodegradable is. Okay, these are waste that naturally they can be decomposed by what? Microorganisms into what? Simpler substances like the carbon dioxide, water, methane, and the compost. That's a byproduct of what? Decomposition. And these byproducts are very useful to us. Okay, and examples of waste that can be broken down by microorganisms, otherwise known as biodegradable waste, are we have the food waste, we have fruit and vegetable peels, we have animal manure. Okay, we have wood. Wood can also be broken down by microorganisms. That is why you see that wood sometimes after sometimes you see these powdery substances coming out of the wood. That is because organisms have acted on it. Okay, and this microorganism breakdown, this biodegradable waste are broken down by microorganisms through two processes. Okay, we have the aerobic decomposition and the anaerobic decomposition. Okay, aerobic decomposition has to do with breakdown of organic waste, breakdown of waste in the presence of oxygen, and this produces the CO2. While the anaerobic decomposition is a breakdown of waste by microorganisms in the absence of what? Oxygen. Okay, and this helps to produces methane and also the biogas. Now, the importance of the biodegradable is this. After this waste are being broken down by microorganisms, we are able to get what? Compost. We are able to what? It produces compost that what? When they are used in our farms, it increases soil fertility and also what? Improves the structure of the soil. It also generates biogas. Okay, it generates the biogas. It causes odor if not managed, of course. In the course of decomposition, it will release a lot of odor. Okay, then we have the non-biodegradable waste. For the non-biodegradable waste, it's just the opposite of biodegradable. They cannot easily be decomposed by microorganisms. Yeah, and it takes a very long time to break down. And examples are, we have the plastic, metals, the glass, electronics, etc. Characteristics of the non-biodegradable waste. Let's look at some of the characteristics. They persist in the environment, of course. You know, for the biodegradable, once they are broken down, right, they turn to compost. They turn to another form of energy that are used. But for the non-biodegradable, for a very long time, the waste are still what? Persistent in the environment. They are still there because they are not broken down. And of course, because they are still there, they cause long-term pollution, right? But one good thing about it is that they can easily be what? Recyclable. That is the truth of the matter. The fact that they are non-biodegradable, they can be recycled to get a useful product. So the last but not the least we mentioned for the biological characteristics, which are the pathogenic. Remember I said for the biological characteristics, the biodegradable, the non-biodegradable, and then the pathogenic, disease-causing organisms. Okay, and examples are the hospital waste. We have the used syringes, contaminated dressings, and then the laboratory waste. All these are what? All these are under the pathogenic waste. They are important to know because they risk spreading diseases, and then they spread diseases, and also they require special treatment too, like incineration and the autoclaving. Okay. So our next slide is showing basic general principles, criteria for municipal solid waste strategy. And this is a sustainable what? Development. We all know what sustainable development is because it said that these basic principles are for sustainable development. But before then, let's know what sustainable development means. Sustainable development simply means meeting present needs without compromising the ability of future generations to meet their own needs. That the resources we are using now to meet our needs, yes, we use resources to meet our needs without jeopardizing the what? The resources the future generation also needs to meet their needs. And the basic principles or the criteria for the municipal solid waste management strategy are, the first we'll be talking about is the prevention principle. There are 4 principles here. The prevention principle, the precautionary principle, the polluters pay principle, also known as the producer's responsibility, and we also have the principle of proximity and self-sufficiency. Now, let's look at the prevention principle. It says that waste generation should be avoided and minimized as far as possible in order to secure conservation of natural resources, of nature and resources. Of course, we all know that generation of waste is inevitable, right? In our daily activities, waste are being bound to be what? Generated. But in as much as it is what? Inevitable, that sometimes or most times, generation of waste can be avoided. At least the generation will be what? Minimized at the what? Lowest minimum. They will be greatly minimized. So we should try and avoid how we generate what? Waste. So environmental damage, of course, can be prevented at its source rather than trying to repair it, okay? So it is better to stop pollution before it what happens. That is what the principle is talking about. That we should try as much as possible, because we all know that the more these waste are being generated, the more they pollute our what? Environment. So it is better to stop pollution before it what happens. An example in waste management is this. How can we what? Prevent, how can this principle be put into place? Or how can waste generation be avoided and minimized? The first is what? That we should try and reduce the way these wastes are generated at source, okay? Number 2, using cleaner production methods, of course, helps to do what? Prevent waste generation at source. Installing pollution control equipment. This control equipment also helps to prevent what? Pollution. And treating wastewater before they are discharged, right? So when we treat wastewater, like our industrial wastewater now, if we don't treat it, what happens? It what? It leads to algal bloom, which kills our aquatic what? Animals. So it is important that we should treat our wastewater before they are being discharged, okay? And why they are important is that why this prevention principle is important is because, of course, it is cheaper than remediation. It is cheaper to do the prevention now than when you do it, you are trying to correct it. Okay? So it is cheaper to even prevent it. That's why they say prevention is better than cure. And then it also protects public health. Once they are prevented, once the waste generation is prevented at source, it's what? It's minimized at source. Our health, our public health is protected. And also it do what? It avoids environmental degradation. Our environment is what? Protected, our health is protected, and it is what? Cheaper than remediation. Okay? Now, how can we avoid waste? How can this prevention be done at source? This can be done. An example of such is what? Minimizing waste. When we design our products with less packaging, instead of cleaning up plastic later, okay? We should try as much as possible that when we are designing our products, that product should have less packaging than having the packaging and then you're now trying to clean up at the end of the day. So the second one we'll be talking about is a precautionary principle. This implies an obligation to take necessary measures to prevent or mitigate impact. Are we saying that we should want an obligation to take necessary measures to prevent or mitigate impact from waste on environment, on human health and the environment? Especially hazardous substances in the waste should be what? Avoided. Okay? Now, what this is saying is this, that if an activity may cause serious environmental harm, and that activity even lacks full scientific certainty, okay, that we should do what? It should not be used. That product should not be used, even if it lacks scientific certainty that it can cause harm. That the fact that we have already perceived that what we are using can cause harm, even without proof, that we should do what? We should avoid it. Okay? The fact that something might be dangerous, and that the fact that something might be dangerous, that we should act carefully, even though there is no complete scientific proof. I think that's the best way to say it for you to understand. Okay, anything we know can cause harm to the environment should be do what? Avoid. That's the precautionary principle. The polluter's principle, which is the producer's responsibility, is that waste generators, especially producers, putting products and packaging on the market should pay the full cost of what? Collection, transportation, waste treatment, and what? Disposal. This has to do with what? Producers. That it is their responsibility. It is their responsibility to do what? To do what? To pay full cost of what? Collection. Because of course, as they are producing their products, they are packaging this what? They are packaging this product. And this packages causes what? Pollution. Okay, so the person or the company that causes pollution as a result of product packaging and all that must bear the cost of managing and controlling it. I think if that is done, these producers will look for another possible means of what? Repackaging their products. Because when you bear the cost, when producers bear the responsibility of what? Managing and controlling controlling waste, I think it will tell on them too. Because when they pay once, they pay twice, three times, they will think of another means of what? Packaging their product. So all these are ways of what? Managing our waste products. And the principle of proximity, okay? The principle of proximity and self-sufficiency. It secures an adequate infrastructure by establishing an integrated and appropriate network of disposal facilities. That waste should not be transported from area unless there are no other what? Options. So this is telling us that waste should be treated, or the disposal of waste should be treated or disposed of as close as possible to where it is generated. Yes. That where we are treating the waste that are being generated and where we are disposing waste should be close to us. Why? Because it reduces transportation costs. You cannot generate waste in Makurdi and you are transporting that waste to Lafia to go and treat and dispose. It doesn't make sense. Imagine the transportation cost, right? And of course, imagine the environmental risks that will be involved. God forbid that car encounters an accident and the waste in the car being littered all over. Of course, it will lead to environmental pollution. Or even in the course of transporting the waste from Makodi to Lafia, you see that some of the waste, even those that are into collection of this waste, you see the way they just put the waste in the truck, at least from my experience, the one I see close to high level, they just put the waste, and as they are driving, the waste are being littered around, right? And then it also reduces carbon emission. The fact that the waste are treated close to where they are being generated, it reduces the carbon emission and also prevents illegal dumping. Okay. Then, yes, I think that is it about the sustainable development. So we have the next slide is talking about the waste hierarchy, the basic general principles. Of course, we are still talking about waste management, right? And we said that in managing our waste that is being generated, we are talking about how to manage this waste from the point of generation to the final word, disposal. Now, it is not just by generating, this management is not talking about just generating the waste and final disposal. There are step-by-step processes that leads to final word, disposal, that helps us to manage this waste. Of course, our main priority while we manage this, we are not just managing waste because we want to manage waste. We are managing the waste because we want to be protected. We want our environment to be protected, and also for sustainable what? Development. So imagine managing this waste, we follow what we call the waste hierarchy. This tells us the step-by-step process of managing our waste from the point of generation to the point of what, where this waste is being what, dumped. Of course, we know that the first one is to what, to avoid. And this hierarchy, it tells us that this step-by-step process are being followed in order of what, priority. Avoid waste creation is the best, okay? Because when we avoid waste creation, it reduces the amount of waste that is being generated. So after avoidance, the next one is what, to minimize, okay? We minimize waste by doing what? The waste sometimes be what? By reusing, recycle. We have mentioned all those things. There are different ways we can minimize waste. And then by reusing maybe what our products and all that. Then to recover materials, we recover material by recycling, by reusing something, we treat and we process and we dispose and then we dump. So we are going to be looking at it one after the other. Don't worry, we'll come to it. We'll come to this avoid, minimize very well. We'll come to it. So this is the basic general principles / criteria for the municipal solid waste management strategy. So this is the waste what? Hierarchy. The waste hierarchy simply tells us the step-by-step process of managing our waste from the point of what? From avoiding waste to dumping of what? Waste. Integrated sustainable waste management. Integrated sustainable waste management. Now, the integrated sustainable waste management is simply a comprehensive approach to managing waste, okay? This is more advanced than this previous method. This only tells us how to avoid waste by avoiding the waste that is being generated and done. But in this aspect now, right, it's a comprehensive approach of what? Managing waste. So this integrated means it has brought different approaches of managing waste other than the waste system elements. Okay, so it is simply a comprehensive approach to managing waste by combining the technical systems. The technical systems are the waste system elements and the stakeholder participation. We can see some of the stakeholder participation like the local authorities, the NGOs, the service users, private formal sectors, the private informal sector, and the donor agencies, right? And also the sustainable aspects. These sustainable aspects are the technical, environmental, financial, economy, social, cultural, institutional, and the policy work legal. So these components are brought together. Okay, so it is more advanced in the sense that the waste management hierarchy only spoke about how these wastes are what being avoided, how they are what. It spoke about how they are avoided, how they are minimized, the recovery materials through the processes that are used to recover these materials from the waste, how they are treated, the process, disposal, and they are done. But in this aspect, the stakeholders, all those that generate waste and are affected by this generation of waste are brought into considerations. They are the stakeholders. And then at least they have their role to play in management of waste, and also the waste system elements are also put in use to manage waste. And the last aspect for sustainable development is the aspect of the sustainability aspect, which is the technical and what have you. Okay, and this helps us to achieve a long-term environmental protection. Okay, it helps us to what? So it is not just collection and disposal, like I said, it also integrates various aspects such as the technical systems, right? The people, that's the stakeholders, the financial and the legal systems, and also the environmental sustainability. Now let's look at the stakeholders. Okay, these stakeholders, if you look, it shows the different actors that are involved in what? The waste management. The actors, the people that are involved, they are the stakeholders. The local authorities, the NGOs. Now, the local authorities, what they do is they are responsible for regulation and service what delivery. All of them have their roles, like I have mentioned. The NGOs / the CBOs, what they do is community awareness and support. The service users are the households and the businesses, and then what have you. And then of course, we know that waste management is not just about the government alone. Okay, in managing waste, yes, government are usually what accountable when it comes to waste management, but it is not just about them alone. It is about the government, it's about the private sector, communities, and the what informal sector, and that is why it's called integrated. So we can see that the integrated sustainability waste management, there are all ways of what managing our waste, but they are most what multitasked, right? And then the waste system elements, if you check the middle from this pictorial view, we see the waste system elements. And the waste system elements are technical stages of waste management. We can see generation and separation, we can see collection, transfer and transportation, then treatment and disposal, reduction, reuse, recycling and what? Recovery. So all these are the step-by-step waste system elements, step-by-step processes of what? Managing our waste, right? And then, of course, we know that disposal is the last option. So the aspect means are these waste managed? Okay, the stakeholder is who are involved in managing this waste. Who are involved? We have spoken about the actors that are involved. Look at them. And then the waste system now is what is being managed. At the step by step. And then now the aspect now is how is it managed? Okay, that's technical, environmental, financial, social, cultural, institutional policy. It tells us what how these ways are being what managed. And let's look at the technical, for instance. It talks about the equipment use, the technology use, and the infrastructure. We have to what use all these infrastructures that helps us to minimize waste. When we talk about environmental, we are conscious of environmental pollution, resource conservation, and the climate what protection. Okay, and then financial means the cost recovery and the budgeting. So you see now how the waste are being what managed. Okay, so of course we know that a waste system can fail if technology is good, but the funding is poor. Do we know that a waste system can fail even if the technology is good, but the funding, that's the financial economic aspect, is poor? It means the waste system can fail. Also, if the law that exists in managing waste, if laws exist but enforcement is weak, waste system can also fail. There is law on ground, but enforcement is weak, right? I'm sure that is what is happening in Benue State. We can see a lot of dump sites, waste being dumped in several areas of the state capital, different parts of Makodi, a lot of dump sites. Not that the Bensesa and the Niger and what have you, not that they don't have laws that guides collection of waste, that guides this dumping of waste and all that. But enforcement is weak. They are not doing their job. Sorry to say, right? And also, when the communities do not cooperate, right, the system will also what fail. So what the integrated sustainable waste management does is that it considers all these aspects put together. Okay, it considers this aspect put together. And when we see this arrow pointing to sustainability is labeled process time. Okay, what it means is that when that waste management, that we should know that waste management is not a one-time activity, that it improves gradually over time through continuous development. It takes time to process, right? It is not just at once you arrive at that place. No, it takes time. Okay, it takes time, gradually over time through continuous what development. And of course, I've mentioned what sustainability means. Sustainability means environmentally safe. It means it is economically, it is affordable. Socially, it is acceptable. Institutionally, it is what supported. So there are various meaning of what sustainability. Okay. So let's go to the institutional framework. Okay, institutional framework. The municipal solid waste management will always remain a responsibility of the public authorities. Okay, from our previous slides where we're talking about the stakeholders, right? That there are various actors. These actors are the stakeholders. Stakeholders are the people that determine how these waste are being handled. Okay, and I mentioned something. I said that even though the municipal solid waste management remains a major responsibility of the public authorities, and that it is critical to rationalize these responsibilities, that institutions must have autonomy. Okay, they must have autonomy and authority, and they must be accountable for service performance. Now, let me summarize what this slide is talking about. That municipal solid waste is what? Ultimately the responsibility of the government, we all know. And this government can be local government, it can be state government, it can also be federal government, right? That even if companies that collect waste, all these private companies, there are private companies that also collect waste. That even if, and of course, that's the stakeholders, the different stake. Even if private companies collect waste, of course, those companies must have the license. The NGOs are also involved. We made mention of the NGOs and the CPOs. That even though they are involved, government is still accountable. Okay, and waste management, of which we know is a public service, government cannot completely avoid it. It's not possible. Just like how water supply and sanitation, they are public services. Waste management is also public service. So, and because of that, the government, they cannot shy away from it. They cannot completely abandon it. Okay, and that is why it is the responsibility of the government. Okay, now, to rationalize the responsibilities means that the responsibilities must be clearly defined and structured. The various institutions must have authority, that's the power to act. These various authorities that are involved in managing this waste, they must have power to act, that is the authority. They must have the freedom to operate. That's the license I was talking about. Okay, that's the license that even though the government is the sole responsibility of the MSWM is sole responsibility of the government, that there are institutions that are also involved. These institutions can be private institutions, they can also be NGOs. That these people must have the license, that they must have the authority, they must have the autonomy, and because they have the power and the autonomy, they should also be accountable, answerable for performance, right? And this is important because no one is held responsible, and service becomes what? The responsibility are unclear if the service becomes what? Inefficient. So they must be accountable, answerable to their for their performances that are involved. Now, waste collection should be handled at the local government. Because if you check the slide, it says that waste treatment and disposal, they may be better organized at the No, waste collection is usually best organized at the lowest functioning level of the public administration. Waste collection should be handled at the local government, because at the local government, local authorities understand the local needs. Okay, at least they are close to each other, they interact, and they understand themselves more because they are closer to the people, and they can also respond faster. Okay, for instance, now let's look at this example that Makurdi local government managing waste collection within its area, because of course the Makurdi local government is in Makurdi, the people are in Makurdi, they are close to each other, and Makurdi local government can respond quickly instead of somebody from afar before they start traveling. Right? And then waste management, the treatment and the disposal facilities are expensive. And that is why it states here that waste treatment and disposal may be better organized on an intermunicipal or regional basis. Why? Because these treatment and disposal facilities like the sanitary landfills or the incinerators, they are They are expensive. And because they are expensive, it is better for several municipalities to share one facility. Okay, it is better for them to share one facility. Why are they sharing one facility? So as to reduce costs. Sometimes these facilities are so expensive, okay, to purchase, and so it is better to share one facility so as to reduce costs and better technology possible too. They can also, the financial burden can also be shared. For instance, several local government areas sharing one engineered landfill. Okay, remember what a landfill is, where the final disposal of waste is what is being handled. Okay, and the private sector, separate the roles of the service organizers, operators, and regulators over time. This is very important because the organizers, the operators, and the regulators, they have different roles to play. Like the organizers, they plan and they arrange the waste services, okay? These organizers are usually the government, right? Then the operators, what these operators do is that they carry out waste collection or the treatment. These operators can be public or private, okay? So after the government finish organizing, the operators, they carry out the waste collection or the treatment, and the regulators, they try to monitor and enforce that these standards, okay? They try to monitor and enforce the standards, and they ensure that environmental compliance is being what done, right? So, and of course, you know that, let's check the next slide. Now, the next slide tells us functional elements of solid waste management. The activities associated with the management of solid waste. Please, class, I think for those of us that are joining lately, if you watch, this material is almost like talking about the same thing over and over again, right? Please, class, are we together, please?
Yes. Well, with you,
Yes,
I'm
ma.
ma'am.
the only one. I hope I'm not the only one doing the talking.
No, we are here.
I'm not talking to myself, right?
No. Yes, you are not talking to yourself. You are talking to
Are we
We
us.
can hear you,
understanding?
ma'am.
Are we understanding?
Yeah. Yes.
Okay, is the lecture, is the course an interesting course?
Yes.
Yes, ma'am.
Yes,
Very
ma. Yes,
interesting.
ma. Very interesting.
Okay, that's very good. I'm happy to hear this. So we can see that it's an A course, right?
Yes,
Because
ma'am.
because at this point in time, this present slide is talking about functional elements of solid waste management and strategy, right? And we have spoken about this before. It's just like a repetition. Okay, so it's just like a repetition, and it helps us to understand what we are talking about. You see that these basic terms, they are interlinked. So now let's look at what the slide is talking about. The activities associated with the management of solid waste, right? Of course, before we manage waste, it must be, our management has to start from the point of generation. If we don't generate waste, can we manage waste? The answer is no. Okay, so this management of waste is coming in such a way that these waste that are being generated will not overwhelm us. Because if it overwhelms us, it will be detrimental to our health, which means our public health will not be protected. Why? Because when these wastes are being generated, when there are too many to control, it will litter the environment. It will lead to what? Environmental pollution, environmental degradation, and it will also affect public health through the what? It will a kind of what? Invite rodents, flies, and all that, which is not good for the environment, right? So the activities associated with this management from point of generation to disposal have been grouped into what? 5 elements. Remember, we spoke about the waste hierarchy. I hope we remember, I told you that we are going to be coming to it again. Because after that pictorial view of the waste hierarchy, we now went to integrated municipal solid waste management. So we are coming to that waste hierarchy properly now. Okay? Okay, so this generation, that is the avoidance. Now let's look at now. So we now said that from the point of generation to the final disposal, it has been grouped into 5 functional elements slash strategies. The first is generation. We know what generation is. That's creation of waste, production of waste. Okay, we'll be talking about them one after the other. The second one we'll be talking about is recovery, right? That's where we'll be talking about how do we recover waste. We recover waste through recycling of the waste, through reuse. That's what we're talking about. And then the treatment process, disposal, and the dumping. We have mentioned this before. But for the sake of those that joined late or that did not understand, I think we'll be able to understand very well now. So let's pay attention. Please, class, can you give me a minute of your time or two? I'm coming. Hello, class.
Okay,
Yes,
ma.
ma'am. It's okay.
Okay, ma.
Yes, please let me use the restroom. I'm coming.
All right.
Okay, can we continue, please?
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so we said that the activities associated with the management of solid wastes from the point of generation to the final disposal have been grouped into 5 functional elements slash strategies. And the first is generation. So we are going to be taking them one after the other. Okay, let's talk about this before we go to the next slide. Now, like we mentioned earlier, we said, I'll just summarize what each of these elements are talking about. Waste generation is the production of waste at source. Okay, and I said that examples of such waste are the cooking, the drinking bottled water, and the cooking can be food scraps, right? Or leftover food. Drinking bottled water like the plastic bottles, and we also have dust and debris. We spoke about the commercial waste, industrial waste, we mentioned the examples, and for the commercial waste, we said packaging waste, restaurant waste like the leftover food, office waste like the paper waste. And I said that commercial waste is waste that are produced from what? Business centers, anywhere business is carried out, right? Industrial waste are the waste from the industry. This can be metal shavings, this can be sludge, okay, chemical processing, which are generated from the chemical processes. And we also have what we call the fly ash from the power plant, okay? So one thing for sure is that waste begins at the point of human or industrial activity. So the second we'll be talking about is the recovery. For the recovery, we'll be talking about the recycle and reuse. What is recovery? Recovery simply means what? Extracting useful value from waste. Anything that is useful that can be recovered. Now, for instance, on social media, I think on Facebook, there is this lady that uses these sport car tires, right? She uses it and then she develops it into cushion chair, this center table, and even these chairs they sit on. Very beautiful. So you can see how instead of burning the tire that will release hydrocarbons in the air that will pollute the environment, you can see how that tire has been used to what? She recovered a cushion chair from the what? From the waste, which is the what? Which is the tire
Reuse.
reuse. Means when you are reusing a bottle, like these plastic bottles, you can see all these occasions, like these wedding ceremonies, functions, burial, where they use bottle water. At the end of the day, waste pickers, they pick this bottle water and either sell to people that sells this home
Kunu.
drink, like this zobo, kunu, soybean milk, right? So you see that they reuse the bottle, they wash it, and then they put what we take inside. So even old clothes too can also be reused as cleaning rags. Okay, and then uh, you can recycle paper into cardboard paper too. So there are a lot of activities that has to do with recycling and what the reuse of waste. For the waste treatment slash process, this involves changing the physical, chemical, and biological nature of waste to reduce the volume. Okay, not just the volume, to reduce the toxicity or environmental impact, right? And for the biological treatment now, I've mentioned composting organic waste and anaerobic digestion. We also have the thermal treatment. And then we have the chemical treatment, such as neutralizing acidic waste, stabilizing heavy metal sludge, and we have the mechanical treatment as well. And then for the waste disposal simply means the safe and the control final displacement of waste. At the end of the day, those waste that cannot be reused or recycled, what do we do with them? Yes, of course, what we do with them is to dispose them. And the question now is, our mode of disposal, is it just to the open dumping, or you just go and throw the waste somewhere? No. Like we said, that the best place to dispose our waste is a sanitary landfill. That is because, and we know that sanitary landfill are engineered structures that are used to dispose waste. Okay, we have the sanitary landfill, we have the engineered hazardous waste landfill, and the deep burial of the treated medical waste. Dumping simply means uncontrolled, unsafe disposal and waste without environmental protection. And that is why, if you remember from the waste hierarchy, dumping is the last and it is painted with black. That is to say that that shouldn't even be an option because of what? Because it is dangerous to environment, right? So an example of that dumping is open dumping in vacant. You just see a land, because that land is vacant, you now start dumping. And then you throw waste into rivers, the roadside waste heaps, and then you burn waste in open areas. All these are not good. You should desist from practicing it. Okay, because why this open dumping is bad? Dumping is bad is because it can pollute our groundwater. It can lead to air pollution. It can lead to spread of diseases. Also, when we dump waste like plastic, nylons, debris, all these broken bottles, rags, they can block our drainage system, and this will what? When our drainage system is blocked, it leads to high accumulation of water that can lead to flooding. So disposal is controlled while dumping is uncontrolled. That's the difference between disposal and dumping. You can control disposal, but you cannot control dumping. You can control disposal because disposal of waste is what? Waste is being disposed in a sanitary landfill, right? That controls everything about waste. But dumping is uncontrolled, it's in the open air. And of course, it is not good at all. So what does it mean? Okay, now for instance, now waste management. Okay, so let's look at waste management. Management, as we know, involves the reduction in the volume of waste, right? How can we reduce the volume of waste? Avoidance and minimization of the generation. So, and we said that avoidance is the most desirable as it ensures that what our material resources are completely utilized, which means that once we avoid waste, little or no waste is what generated, and even yes, little or no waste is what generated. Waste minimization, of course, is not a technology. It is not a technology, and as such, there are ways it can be achieved. There are ways is what? Source reduction. That's prevention. And this is waste avoidance. We try as much as possible to avoid the amount of waste that is being what? Generated at source. Another one is to reuse products. I've mentioned products that are what? Reused. Some of these waste products are being reused and they become useful products to us. I made mention of the tires. The tires that were thrown away and are being reused. And even the bottles. The bottled water that have been thrown away and they are reused to put things inside for sale, like the Zobo drinks and what have you. Then remanufacturing, recovering for recycling, composting, but not by treatment. Okay, so we recover waste from recycling of this waste, remanufacturing, composting. So all these can be achieved. Waste management can be achieved by all these processes. So we have made summary of this waste minimization approach now. It's just trying to explain what we have mentioned, okay? So I'm not going to be talking much because I think we have limited time just, but as we go along the slide, at least so that at your leisure time when you are reading, you'll be able to understand. So let's look at what the slides are talking about. Waste minimization, of course, we have mentioned it before, includes source reduction practices that reduce or eliminate waste generation at the source, and environmentally sound recycling processes where source reduction is not economically practical. Source reduction includes any practice that reduces the quantity. Of course, whatever we are doing, let's take for instance, right? It is better to buy food. Of course, the truth of the matter is all fingers are not equal. But one thing for us is what we plan our lives. It is better to buy food in bulk than to buy food in smaller quantities. For instance, if we are buoyant enough, it's better to buy even half bag of rice at a time, or even a bag of rice and keep in the store, other than going to the market and buying one mudu every week. Because as you are buying, they are putting it inside what? A packaging material, like your nylon, right? So let me ask now, imagine buying every week you buy a mudu of rice. Imagine the amount of waste you will generate even before the half of the year. Because for every mudu of rice you buy, they package it in the nylon for us. And of course, when you finish using the rice, what do? You throw the nylon. So it is better to buy food in bulk. That will help us to generate waste a lot from the source. Also, even this market bago bag, bago bag we take to the market, it is better to always take the bag. Each time we want to go to the market, let's go with the bag so that because it can contain a lot of food stuff inside at a time. Instead of for every market you are going, you buy the bako bag, throw away. The next market you go and buy another bako bag, you throw away. How many bako bags do you want to waste at the end of the day? So we should try as much as possible to practice activities that will help us to reduce waste at source. Source reduction includes any practice that reduces the quantity and or toxicity of pollutants entering a waste stream. prior to recycling, treatment, or disposal. Do we know that if we reduce waste at source, it will reduce what? It will reduce what we are supposed to recycle, it will reduce what we are supposed to treat, and it will reduce our disposal. And it will even help disposal at the end of the day. Of course, we know that it's like sanitary landfill. So it will help our landfills not to be what? Not to be compacted or not to be full on time. Of course, we know how expensive it is to build our landfill. So if we manage waste from the source, we try to reduce the amount of waste that are being generated at the source, I think this will help the other step-by-step processes too. So examples, how can we minimize waste at source? By using technology modifications, redesigning of products, substitution of less toxic raw materials, improvement in work practices, maintenance, worker training, and better inventory control. So another approach is the reusing of items. We reuse items by repairing them. We reuse items by donating them to charity and community groups. We reuse items by selling them to reduce waste. Now, it is expected of us to use a product more than once. Just like how I said, like the bako bag we use to the market, either for the same purpose or for different purposes. Reusing, when possible, is preferable to what? Recycling. Yes, of course, because the item does not need to be reprocessed before it can be used again. You can't compare reusing a product and recycling it. The stress to even recycle a product can even discourage a lot of people. But the situation where that product is still intact and can be reused, of course, you just go ahead and you reuse the product. And that process helps to do what? To minimize the amount of waste that is generated. Remanufacturing is the restoration of used products, right, or components to a condition with performance characteristics approximating those of a new product. So remanufacturing is also a way of waste minimization. Now, there are certain things we have to know about waste minimization. It is said that recycling or reclamation of waste, of course, we know that a material is reclaimed if it is processed to recover a useful product. That is what recycling means. That is what reclamation means. When you process, when a material is processed to recover a useful product, or if it is regenerated. Okay, so buy if you have the choice recycled goods. So it is better to recycle our goods instead of buying. Then composting. Composting is another form of recycling. Okay? Composting is another form of recycling where our organic waste is converted to what? Organic manure that can be used on the farm. Composting is a controlled biological decomposition of organic matter. We have said this before. This is just a repetition. Such as food and yard waste into humus, a soil-like material. Composting is nature's way of recycling organic waste into new soil, of course, used in vegetable and flower gardens, landscaping, and many other applications. So we can also reduce our waste by what? Turning some into compost manure that can be used on our farms through the process of composting. By doing so, we have tried to reduce the amount of waste that was generated. Then the waste treatment is any process that is designed to change the physical, chemical, or biological character or composition of waste. For example, compacting, neutralizing, diluting, incineration are not waste minimization processes. They are not waste minimization practices, nor is burning waste to recover energy. Okay, so waste treatment is also a process that is designed. We know what waste process is. So all these other ones that have been mentioned, compacting, neutralizing, diluting, incineration, they are actually not waste minimization practices. So of course, because these ones we are talking about now, they are done. This is waste to energy, right? This is waste to energy because from compacting, neutralizing, all these ones, they release energy. Okay, they release energy that are used by industries. Then what are the advantages of waste minimization approach? Waste avoidance, like we all know, it has the highest rank in the hierarchy of integrated solid waste management. Because for every ton avoided means that there is a ton less that needs to be managed. That is true. If we refuse to generate waste as source, it means for every ton of waste that is not generated leads to what? A ton of waste that needs to be managed. It's being avoided. The more you generate waste, the more you manage waste. So that ton of waste that you do not generate, that ton of waste will not be what? Managed. So it is very important to always manage waste at what? Source, by avoiding the way that the waste is being generated. Minimization plays a critical role in reducing waste quantities by reducing the financial and environmental burden of what the municipal solid waste management. And that is why they say charity begins from home. Do you know that generation of waste at source starts with us? It starts with what? All those municipal solid waste that are being generated. When we are conscious of the way we generate waste, the government does not have to what? Labor much. That burden, that financial and environmental burden of managing solid waste at least will be reduced on the government, and it will lead to a sustainable environment. Minimization will become even more critical as quantity of waste and in particular consumer packaging increases. Yes, let's look at the advantages of waste minimization. Advantages of waste minimization approach. Because of its obvious advantages, waste minimization has a number of implications for general waste management. The first is should be a central waste management priority. Why? Waste generation is a function. High level of waste generation occur when high level of financial resources are spent. Yes, especially if urban is turning to rural. Of course, urban waste is mostly organic waste. Where urban is turning to rural, there will be more of what? Consumption. There will be more of packaging materials, right? So minimizing waste generation therefore depends on introducing economies that what reflect waste management costs and on accountabilities that assign responsibility to those who generate it. When responsibilities are assigned to those who generate it, at least they'll be conscious of the kind of waste that they generate. So, on the other hand, individuals and organizations make decisions to generate less waste, but the ability to do so is compromised by an economic environment in which the waste generators have little or no accountability for waste generation. So, within the environment, the short-term impact on total waste quantities of individuals or organizations who choose to reduce the amount of waste we generate is what? Small, right? So, these are the advantages of waste minimization. So let's go to source reduction. Source reduction is waste prevention, and it includes many actions that reduces the overall amount of waste. Waste avoidance by reusing a product when possible is referred to recycling. Use a product more than once. Refilling bottles I've mentioned. That's why I said I will not waste time on this again because these are things we have discussed already. Using each side of a paper. Yes, in a business center, for instance, like handouts, student handouts. You will notice that student handouts, they try to photocopy on each side of the paper. But in order to reduce the quantity of papers that are being used, it is better to use both sides of the paper sheet to do your photocopy. That way, instead of a document that needs 10 papers because you are photocopying on each sheet, if you do on both sides, at least it will be reduced by half. That is 5. So that is a way of what? Reducing or money, that is a way of what? Reducing waste as source. Also, reconsider your daily routines and habits. Whatever we are doing in our daily routine, we should make sure that the best option we choose at the end of the day will be an option that will help us to reduce waste at source. Reconsider repairing before throwing. Whatever you are having, even though you have enough money, even though you are buoyant enough, right? Instead of throwing what you have and you know it can be repaired, it is better to repair it than to just throw it away. And if you don't want to repair it, you dash somebody that wants to make, and then reuse of excess what material. If you have excess material you want to reuse. So the benefits of source reduction are source reduction and reuse. It is important to reverse environmental impact and saves natural resources. Communities, because less waste has to be. It is important for the industry because products can be produced with less raw materials. Yes, it is also because it reduces the prices for the products and the fees for the disposal. Source reduction has a number of implications for waste. Simply put, source reduction is waste prevention. Please, like I said, this is what we have discussed, but let's just to be able to understand more. It includes many actions that reduce the overall amount of toxicity of waste created. Source reduction can conserve resources, reduce pollution, and help cut waste disposal handling costs. You see the importance of source reduction, right? It avoids the cost of what? Recycling. Of course, if waste are not generated at source, the amount of waste that will be recycled will be reduced. So which means it will avoid the cost of recycling. The amount of waste that will be what? Composted and landfilling and combustion will reduce drastically. So it avoids cost for us. Source reduction is a basic solution for garbage plots. Less waste means less of a waste problem, of course, because source reduction prevents the generation of waste in the first place. So it becomes it comes before the management options that deal with waste after it is already generated. And after source reduction, like we all know, recycling and composting are the preferred waste management options. Yes, because they reduce the amount of waste going to landfills and conserve resources. That is true. Putting source reduction into practice is likely to require some change in our daily routines. Okay? Yes, of course, when we are conscious of the amount of waste we generate at source, to affect the way we live our daily life and the kind of activities we carry out. Changing habits does not mean a return to more difficult lifestyle, of course. However, in fact, just the cost of waste disposal will continue to increase. Yes, the more the waste are being generated, the more the economic and social cost of waste disposal will increase. And communities, more urban and suburban, face increasingly harder decisions about managing their waste, right? So that is all about source reduction. Now we are talking about recycling. When we talk about recycling, it involves the separation and gathering of waste materials, preparation of these materials for reuse, processing, manufacture at the manufacture recycling facility. So there is a facility where waste that are meant to be recycled are being taken. So before we recycle waste, especially when separation of waste was not done at source, so there is need for separating and gathering of these waste materials before they are recycled. Okay, so reuse, reprocessing, and remanufacturing of these materials by industry. So it is important. It is an important factor to reduce natural resources and the amount of waste requiring disposal by landfilling. What are the advantages of recycling? Recycling falls within the second highest rank in the hierarchy of integrated solid waste management. Okay, so it is the second highest rank in the hierarchy of the integrated solid waste management because every ton that is extracted from the waste stream means that there is a ton less that needs to be managed. We have mentioned that before, right? So recycling therefore plays a critical role in reducing waste quantities, returning resources back to use, right? Because when we recycle our waste into a what? Into a useful product, the resources that are supposed to be used to produce what that useful product is being conserved. Okay, so and of course it minimizes the financial and environmental burden of municipal waste management. Recycle will become even more critical as the quantities of waste and in particular consumer packaging what increase. I think this is the last slide we'll be treating for today. Tomorrow, this is the last slide we'll be treating for today. Tomorrow when we come, we'll complete the other part of the slide, after which my second will take over the remaining days. Okay? So the recycling, now this is a closed cycle management of substances. The recycling cycle is as follows. Now, prime material simply means raw material, material that has not been processed before, right? Of course, we use raw materials for our. So when we use for our production, they are being utilized. When we utilize, it be a used product. Some of the products we discard them as waste, and there is need for us to recycle some of the products, and you see the cycle continues. You see that the recycling process what continues. So we have the prime material that has been recycled to production, and then from the production they are what utilized, they are being used by consumers. So the products that are being utilized by consumers becomes a used product. These used products can be regarded as waste, and some of the products can be recycled, and the cycle continues. Now let's read what is on our slide. Extraction and exploitation of prime materials to be ready for processing. Processing and manufacturing of the materials into goods, and then utilization of the goods by the consumer. That's what I've explained, and that's what the write-up is talking about. Then separation of the used packaging and the used products. For a proper recycling to be done, because the way we recycle organic products is different from inorganic products. So there is need for separation of this word, used packaging and this used products, before recycling can be done. Recycling of valuable materials in such a way to turn them into new products and enter the cycle again. Non-valuable waste residues are usually disposed of as what? Waste. Okay? So the waste that are not valuable again, that are not valuable and are residues, after the recycling, you must still get residues. So those are the kind of waste that are disposed of as waste. So by entering the cycle, used products would have otherwise become a waste will minimize the quantity of waste destined for disposal. Clearly, not all secondary materials can be recovered in a efficient way, and not all secondary materials have a high market value, of course. Material recovery has to be seen as a component of an integrated municipal waste management control. Aluminium counts usually lends itself to recovery if related industries, the most obvious cause for scrap aluminium. So we have just 2 minutes left. So if you watch, in our next class, we'll be talking about the recyclable materials. Okay, so we have spoken about recycling. We went ahead to talk about advantages of recycling, and now the closed cycle management of substances, how this recycling process is what done. Okay, so tomorrow, by the special grace of God, we'll be talking about the recyclable materials. There are different materials that can be recycled, and each of these materials are grouped into sectors. They are grouped into types. So this will help us to what? We have made mention of the facility where our recyclable, those materials that can be recycled and remanufactured, that they are taken to that the manufacturing recycling facility, where separation of gathering of these waste materials are done before the recycling can what take place. So I think for now this will bring us to the end of today's lecture. Are we there, please?
Yes, ma. Thank you, ma, for the lecture.
Thank you so much, ma.
Yes.
Okay, I have some charts here. Let me see. Hmm. So do we have any question? This is an interactive class. We are going to
Yes,
ask questions although time is against us.
yes, ma. I have a question to ask.
It's time over already.
Ma,
But you can ask your question.
ma, we're not going to have our afternoon lecture. We usually have morning and afternoon. Is afternoon going to
Yes,
be?
yes, yes. Yes, there will be no afternoon lecture. This is what is going to happen, okay?
Okay.
This is what is going to happen. We have how many days for this course? How many days of lectures for this course?
5
5
days.
days. 5
5
days.
days.
Okay, 5 days, right?
Yes,
So
ma.
for the period of the 5 days, we'll be having 2 hours lecture per day.
Okay, okay.
That's the 9 to 11, right?
Yes.
Okay, ma.
Yes, and I'm going to be taking the first 2 days, that's today and tomorrow. I'll be taking today and tomorrow, and my second will come and take from the 3rd day to the 5th day. I hope it's okay by us.
Yes.
Yes,
Yes,
ma.
ma.
Yes. So don't be confused and don't come and be asking of afternoon lectures, okay?
Okay,
Yes,
ma.
ma'am.
Thank you.
Okay. So I wish you guys all the best till tomorrow, eh?
Thanks so
Thank
much.
you.
Thank you, ma.
The material.
Yes, I'm going to send the material. I'll send the material to you.
Okay.
Yes.
Hello.